Our advanced lecture where we're introducing you to trustworthy machine learning. We're extremely excited to be giving this course here since we think it's a fascinating topic and there are actually not so many teaching resources out there. So while overall this course is currently being held at the University of Saarland in Germany, we plan to upload all our lectures to YouTube such that everybody who is interested in the topic of trustworthy machine learning can follow. Before we get started, let us quickly introduce ourselves. My name is Franziska Böhnisch and I'm a tenure-track faculty at the CISPA-Helmholtz Center for Information Security. My research focus is mainly on trustworthy machine learning with a focus on privacy preservation, but I have also done research at the intersection with other aspects such as model robustness and fairness. At CISPA, I co-lead the SprintML research lab together with my co-instructor for the course, Adam Djedzic.
Hello everyone, so my name is Adam Djedzic and I'm also a tenured faculty member at CISPA and co-lead the SprintML group with Franziska. In the past, I also worked on many aspects of trustworthy machine learning that were especially focused on how to provide more robust models, how can we also introduce collaborative learning where many different parties have their own machine learning models and would like to improve them while preserving privacy of their data. I also work on different aspects of how we can steal ML models and then how can we defend them from being extracted, especially from ML APIs. So with these short introductions, let's delve into the content of this course. So nowadays, machine learning models underpin a variety of services. Thanks to them, we can obtain higher quality translations, for example, of a given text from English to German. And machine learning is a versatile tool also in the field of robotics, enabling robots to become more capable, adaptive, and versatile in a wide range of applications, from manufacturing and healthcare to autonomous vehicles and space exploration. Machine learning models in autonomous vehicles enable them to learn from data and make predictions about the world around them. Machine learning algorithms can be used to identify objects, pedestrians, and other vehicles on the road, and to predict their behavior. Finally, medical professionals can now collect and manage patients' data, identify healthcare trends, and recommend treatments with the help of machine learning. So, machine learning can help healthcare providers to improve decision-making and reduce risks in the medical field. However, the machine learning services fail. This is the Google Translation service, and the user inputs some gibberish. Actually, this was an attack by a malicious user against the service underpinned by machine learning models. And in this case, behind the scenes, there is a neural machine translation system, which is trained with large numbers of text inputs in one language and corresponding translations in another language. This is to create a model for moving to translate between these two different languages. But when this service is fed with nonsense inputs, the system can hallucinate bizarre outputs. And this happens especially for the low-resource languages like Somali. So it occurs that this example is a passage from a Bible. So this suggests that the Google service used Bible to train its model. And since the Bible was translated to many low-resource languages, it's also the case that this model in such situations outputs some fragments from the Bible. And eventually, the service outputs its memorized training examples. Not all machine learning failures are benign. When we start to use machine learning models in a broader set of applications, mistakes can have much more dramatic consequences. A single failure from a machine learning model might result in an accident and even in a human death. Unfortunately, there are a few examples that Tesla cars in fatal crashes were on autopilot. The situation is more challenging when machine learning is released in adversarial setting and the models can interact with explicitly malicious users. In 2016, Microsoft released a bot called Tay, and it started nicely and had many followers. However, it caused subsequent controversy. So the bot began to post offensive tweets through its Twitter account, causing Microsoft to shut down the service only 16 hours after its launch. So Tay's misbehavior was caused by mimicking the deliberately offensive behavior of other Twitter users. Bias in machine learning models can cause its underperformance for specific groups of people. Recently, machine learning systems developed to diagnose skin cancer showed that there's a risk of being less accurate for people with dark skin. So much more needs to be done to ensure that ML-based technology benefits all patients. The main question in this course is what are the risks that impede ML from being trustworthy?
And hopefully now that Adam's example showed you that the risk of trustworthiness is real and corresponds to risk in our day-to-day life, let's walk through some of the risks that we're going to cover in the course in a bit more detail, just to give you a small introduction. And to begin with, let's talk about some privacy risks. So what we saw in the example with the language translation service was that the model actually memorized some of its training data. This means that the model stored some particular sequences that it was trained on. And this kind of storage means also that the data can at some point be reconstructed or extracted, like we saw. And this is what we call reconstruction attacks. So in reconstruction attacks, we have a potentially private training data set, and then an adversary comes and interacts with the model. In this case, like just to give you a schematic overview how a structured attack, where we don't just input gibberish, can look like, I gave you this example of a face classifier. So this face classifier was trained on multiple faces, among them the face of somebody called Alice. And then what an attacker can do actually is to start off with some random data point, just some random noise, and then invert it through the model and see what is actually the prediction performance like for the class Alice. And then optimizing this data point more and more to look like Alice, the adversary could potentially reconstruct the face image and thereby breach the privacy of Alice. Data reconstruction attacks are not the only risks that we face when we interact with machine learning models, but we have other privacy risks, one of them being the so-called membership inference risk. What a membership inference an adversary is concerned with is the question, given a data point and given a trained machine learning model, they want to know what's that particular data point used to train the model. And this can have harmful consequences if sometimes already the membership in a data set discloses some private information. You can think about a classifier that predicts treatments for cancer patients. This classifier obviously needs to be trained on the data of cancer patients. So being in the data set means that the person has cancer. And by finding out that the person is a member of the model, the adversary can then find out that the person has cancer. Moving on from the privacy of the users who provide their data for training the model, we can also think about risks for the machine learning models themselves. So machine learning models are relatively costly to train. We need data, we need to clean that data. For supervised learning, we need to potentially label the data. All that incurs very high costs. So the machine learning models actually become a lucrative target for somebody who wants to just use them as a lower fraction of cost. And when a service provider now exposes their model through an API, which means that people can query the model with their data and then get a prediction, adversaries can steal that model. So how does that usually work? The adversary would just take some own data, potentially just go through the streets, take their own photos, and then query this data to the model and use the model as a labeling oracle. So at the end, the person would know what's the label for the data points, and having data and labels they can actually train their own model, which acts exactly the same way as the model they wanted to steal. And this has multiple advantages for them. The first one is it's cheaper because they don't need a human, for example, to label the data. The second one is they can use that stolen model to craft further attacks because that stolen model is very similar to the target model. One of the attacks that can potentially be launched through such a stolen model are attacks against the robustness of a model. And when we deploy a machine learning model in the streets, like for example, the Tesla cars that Adam mentioned, we want them to do correct predictions. So if they see a stop sign or if they see a give way sign, they should definitely not take the way and be the first to be on the intersection because this can cause deadly accidents. However, unfortunately, machine learning models have been shown to be vulnerable to so-called adversarial examples. What is an adversarial example? Well, imagine you have a normal data point and the model is perfectly able to classify the data point. For example, here, the no entry sign. Now, adversarial examples work that way that they craft careful amounts of noise. This noise is human imperceptible. So for us, before and after adding the noise, the image still looks exactly the same. However, for the machine learning model, internally, some different behavior is triggered such that the model eventually predicts the right of way and then can cause some fatal accidents. Finally, what is a problem and trustworthy of machine learning models is that these models often act as black boxes. So we get access to the model, but we don't actually know what particular parts of the input or what particular parts of the model cause a certain behavior. So this is a big problem, especially when we want to learn about biases or learn how to mitigate biases like the ones that we saw with the skin cancer. And therefore, we have something which is called interpretable machine learning, where we try to find out, like looking at the data and looking at the model, why were certain predictions made? So if we have the benign street sign and then suddenly somebody puts a sticker and alters that, or somebody just adds noise, like with an adversarial example, and the model changes their behavior, then we want to know where that comes from. So I hope that we now gave you a short overview on what are the potential risks to trustworthy machine learning and what we need to be aware of. During the course, these are the topics that we're going to cover, and we're going to look into many more topics, such as collaborative learning and the risks to trustworthiness that arise when there are multiple people involved into training a machine learning model. We'll also look more deeply into fairness and into security of the machine learning applications that are actually deployed. And finally, we'll be discussing machine learning model governance, which is the question of how do we integrate the models into our society and into our life while respecting the social values that we carry. And with this outlook, I hope that you're as excited as we are to the next lectures, and we'd like to thank you for your attention.